Hey everyone, welcome back to another video. Today we're going to get started with Unit 1 for AP Human Geography. We're just going to introduce the course and some of the basic concepts that we need to cover. We're going to look at what maps are, how to read maps, what are regions, what are the different scales of maps. Very, very fundamental information and concepts, not too challenging either. Compared to the rest of the course, this shouldn't be that much of a headache to get through. Yay! I like that. You should like that too. Let's get started though. So I do have some resources for you to use if you'd like to. I have some guided notes for the lectures. They are in order of topic number, so 1.1 to 1.2 to 1.3, as well as multiple choice and free response practice tests, as well as a key terms list. I don't give you the definition for those key terms. You should go out and find those yourself, but there are a list of terms that you should know for this unit. Now, all of my AP Human videos go by the course and exam description. Now, if you have never taken an AP class before, you may not know what this is. So, the course and exam description is a document created by the College Board. They're the same company that makes your AP exams. And they divide the course into different units, into different topics. So, for example, 1.1 is Introduction to Maps. And there are certain standards, like in a curriculum, that you have to be able to meet. And sometimes they give certain information that you have to know. If something is not in this course and exam description, it is not on the AP exam. So everything that I'm teaching you, for the most part, is from this course and exam description, and is supposed to help you for the AP exam. In this course and exam description, you can abbreviate it as CED. That's what I do. The CED. Inside the CED are standards and skills that you need to have on the AP exam, and the skills that you are expected to use. It gives practice multiple choice questions as well as free response questions for you to kind of see what you're expected to answer on the AP exam as well. It's very, very useful. So the concepts I'm going to be covering are taken out of this course exam description. If you'd like to follow along, you can. So yeah, the link in the description, there'll be a link in the description for the CED. So what is human geography? What is this all about? Why are you here? So human geography is considered the mother of all sciences. It's the study of spatial relationships, where things occur, and as well as the human interactions with other people, the places that they go to, and the environment that they hold. So they can include questions like, why do people get married, or when do people get married and have kids? Why do urban cities develop along coastlines, and why do rural settlements typically develop more inland? Where do certain cultural groups migrate to? Why do they migrate to those areas, and what are the effects? Who trades goods with certain countries? What do they trade? How does it impact both countries? How does it impact the entire world's economy? What crops can be grown on the land in a certain country? What climate zones are there? How does that benefit the economy as well as the food consumption within the country? How do political alliances affect oceanic boundaries and marine extraction? How does this create disputes and resolutions between countries and organizations? So we're not just looking at, where mountain ranges are, where rivers are, and where countries are, where continents are. We're not looking at just the physical geography. That's very important though, because physical geography creates our places. However, we're also going to be looking at what humans do to the physical geography and what humans do with each other. So we're looking at human-environment interactions, and we're looking at human interaction with one another within a space. And that's what we mean by spatial relationship. So what can we take away about human geography in this image here? So this is a town in Europe. If you know which country, congratulations. Anyways, what can we conclude about human geography? Well, we can see that there's a certain architecture style. That's a cultural trait between the buildings here. We can infer something about the climate. That's physical geography. We can see the types of trees. I don't know the exact types of trees, but we can see how the humans have handled these trees. They've put them in set clusters here. We can probably determine that there's some parks. They may have them for decorations. We can see that this is a very clustered settlement. The buildings aren't very tall. They're not high rises, but it's still a city area, probably a very historical city area. This is probably in a very developed country, too. So it may have a lot of tourism. It may have a very older population. It may have a low birth rate. So yeah, there's a lot we can take away from this image. Now, if you didn't understand where I was coming from with any of this, don't worry. That's what you're going to learn in this course. It's just to show you that there's a lot to human geography. I mean, we could go over the political boundaries of the town. Maybe there's two towns technically in this image. We could go into agriculture. What's grown? It doesn't look like they have a lot of farming. Can crops not be grown, or is there just a lower need for agriculture? Maybe they import goods from other countries and export manufactured goods, or they have a high service economy. There's a lot we can take away from just an image and a lot about a place, and that's human geography here. So cartography is the construction of maps, and you're going to see a lot of maps in this lecture and in the entire course. It's very important. So, I just have two maps here to show our first two maps, the population density of Kenya and cancer rates in the world. Population is something that gets its own unit in this course. It's so important to understanding human geography. And we can see that there are clusters of population in Kenya. You can kind of see where populations are very located. And you also see on the world map where cancer is primarily found. We can see that it's primarily found in the United States, Australia, Canada, as well as Western Europe. So those are our more developed countries. Cancer rates are particularly found in more developed countries, per se. There's a higher rate of cancer. And this can create a lot of questions like, why does this occur, and where within these countries does it occur? Because it's probably not the same across Canada and the United States. I mean, those are huge countries. So where are the cancer rates higher? My guess is in the urban centers, obviously, because that's where the more people are. So let's go over some types of maps, because there are specific types of maps. The first one is a reference map. So a reference map is what you think of a map on your college dorm wall or in your teacher's classroom or your kindergarten carpet. It's a reference map that provides a general overview of a location, where things are. Where is Africa? Where is Russia? Where is Mexico? Where are these places located? What physical features are there? Where's the ice? Where's rivers and mountains and other physical landmarks? Where are the peninsulas and where are the islands? Sometimes this map doesn't really show it. There could be political data, like where country borders are, where are urban areas in other cities located. What about transportation routes, like interstates? Where's I-95? And as well as other infrastructure, like train stations and bus depots. Particularly, we don't see quantitative data. We see qualitative data. Qualitative data is data that doesn't deal with numbers here. We don't see a lot of quantitative information on our reference maps here. We don't see like the population of each country here or the size of each country here. And so, yeah, it's qualitative data. So here's another reference map. This one shows more of political boundaries and routes. It shows where airports are located. It shows where roads are located, where railways are located. It shows the boundaries between regions. It shows where cities are. It even shows boundaries between countries like Mongolia, China, and India, as well as Russia. So this is still considered a reference map. We're really only looking at where things are located. We're referencing here. We're not looking at a general theme or a phenomenon. Now, that's the job for thematic maps. A thematic map portrays a pattern or some kind of theme or a phenomenon that's related to a specific subject. And a lot of times, if you Google thematic map, you're going to see population, population density, population growth, population decline, immigration, that sort of thing. Those are very popular thematic map topics. This one is who drives the most. And we can see here that, yes, we see the political boundaries between the states and where the states are located. So we can kind of reference here. But we can also get an actual quantitative value, a number from a research study in 2008 on miles driven in each U.S. state. We can see here that there's less miles driven in California in other states compared to states like Mississippi and Alabama or Oklahoma, where more people are driving here. And some states are just kind of in the middle, like Minnesota, Florida, and Georgia. These types of maps, thematic maps, show qualitative and quantitative data. Remember, quantitative data is data that deals with quantities, which are numbers. All right, that's an easy way to remember it, because that's going to show up again later in the course. All right, so here's a type of thematic map called a chloropleth map. I didn't include the L for some reason. It's a chloropleth map. So yeah, what is a chloropleth map? Well, it's what you think of when you think of thematic map. There's different shades to represent different values here. So we can see here that a very bright blue, or dark blue actually, a more dark blue is more Democrat. A light red is a more Republican. A purple, kind of an in-between, is kind of in the middle. And so yeah, that is a chloropleth map. Here's another chloropleth map. It's on coconut production in the countries. What conclusion can we draw from this map? We can kind of say that coconut production is done the most in our tropical countries, in our more middle countries, closer to the equator. There's a lot we can draw from this map, but besides that, we can see here that chloropleth maps use different shades of color to show different values. Most of the time, the darker the shade, the higher the value. So in this case, the darker shaded countries like Indonesia, Brazil, and India produce the most coconuts. They produce over 10 million coconuts per year, which is a lot. Now, where's a cluster of coconut production? Besides, you can't say closer to the equator, because there's a lot of countries close to the equator, but they don't produce coconuts, like Egypt. They don't produce any coconuts for that matter. Well, they produce like one, but where is a cluster of coconuts? So here we're going to look at our regions. We can see that there's a lot of coconuts being produced in Southeast Asia. There's a lot in India and Indonesia, Southeast Asia. We could say there's a cluster of coconut production. And a cluster, if you don't know, is that's where there's just a lot of it located. There's a lot going on, an accumulation. Now let's look at isoline maps. If you have trouble remembering this, just remember isoline has lines, and you're going to see lines that are not boundaries on these types of maps. So a lot of times these deal with climate and weather, like rainfall, or elevation's a big one, or sometimes temperature or heat. So we can see here that it's kind of like a chloropleth map. We're seeing different shades here. However, they're using lines to separate the values. We're not shading in different states. We're shading in where the temperature changes. So it can vary within a state. It could stay the same within a state. In Florida, there's 3 different average temperatures depending on where you are here. So let's look at another one. This is an isoline map on rainfall within Africa and Asia. Yeah, it's kind of like a chloropleth map. You have different shaded values, but there's a lot of line action going on. And it's supposed to be a little more specific than a chloropleth map. It's supposed to give more specific data for you. It's not used that much either. Dot distribution maps. These are used a lot in local maps. Especially where locating like where different places are. So this one's homicides in Washington D.C. from 2004 to 2006. I don't know if that's around the same time as the D.C. snipers. It may be a little earlier. If you don't know what the D.C. snipers are, look that up when you have the time. But here we can see different dots have the same value. They mean the same thing, same value. They mean one homicide. The method can be different, like guns, knives, and other, like the key says here. But one dot represents the same value. That's something to take away here, because we're going to look at a map where they don't represent the same value. That's a whole different type of thematic map. And these are really good at finding clustering and dispersals. Dispersals is where stuff's more spread out, and clustering is where they're more close together here. So we can see there's a big dispersal of homicides in the northern areas of Washington, D.C. here. Here's another dot distribution map. This one's population. We can see there's a big cluster of population on the east coast of Australia and northern Tasmania, as well as a dispersal in South Australia or Northern Territory, or you could say Western Queensland. So yeah, really, really interesting here. And yeah, one dot doesn't have to mean one thing. It can mean 1,000 people. It can mean 200 people. So yeah, there did that. Cartograms. Cartograms are fun because cartograms change the sizes of the entities with their values. So here we have electoral votes in the 2008 presidential election. And we can see here that California has 55 electoral votes. So they're going to be the biggest entity here. While a state like Mississippi only has 6 electoral votes. So they're going to be really, really small. North Dakota and South Dakota have only 3 votes. So they're really, really small. compared to a state like New York that has 31 or Florida that has 27. They're going to be a little bit larger. This is another cartogram, and it's very distorted. I mean, look how like pinched South America is, and then look how bloated Asia and just Asia really is, India and China area. So what data do you think that this cartogram is showing? What do you think it is? I think, and I know, that it's the world population, because the world population is the greatest in India and China. So these are where these are kind of like your dot distribution maps, but they vary in size. And that just means they vary in value. The larger the size, the larger the value, or a percentage, or a proportion. They're called proportional symbol maps. Sometimes you may see them as graduated symbol maps. So we can see here that a small little rain dot is 1 million gallons per day of water. However, the largest drop is 1,000 million gallons, which is a billion gallons per day of water withdrawal. And this is Idaho water usage. So where's a cluster of water withdrawals in Idaho? Where are they accumulated? I would say in southern Idaho, there's a cluster. Where's there a dispersal? Northern Idaho, I would say so. Here's another proportional symbol map here. We're looking at population age in terms of millions of people. So the pink represents population under the age of 5, a very large youth population if it's big. And then the orange represents the population over 60. And if that's big, that represents a high elderly population. So in Ireland, they look pretty equal. In Spain and Portugal, that elderly population is far greater than the toddler and infant population. So that's something to consider here. But you can see that kind of as a pattern here across the continent, that this elderly population is magnificently higher than the toddler and infant population. So that could mean something here, especially in Western Europe. So that could show that Western Europe might be aging at a higher rate than Eastern Europe, or that Europe as a whole is aging. And then this is something that you'll see sometimes on like the Weather Channel, is a heat map. And typically this just shows temperature. I don't know where history came from. It shows temperature. So the more red, the hotter it is. The more pink, the colder it is. It's pretty simple. You could probably tell if they gave you this on the AP exam and asked you what it's showing. You could probably tell, okay, equator's darker, the poles are lighter, it's showing temperature. All right, let's do a little bit of practice here. So what type of thematic map is this? We'll do a few of these. So this one is showing different shades, but it's also showing lines. So it's showing Spain, France, and Portugal, I believe. And the countries themselves aren't highlighted differently. And the lines vary over time. So this is an isoline map. All right, what about this one here? Okay. We see different dots showing population. What type of map is this? This is a dot distribution map. There we go. Okay, what about this one? It shows different shades across the counties of the United States. It's showing the COVID-19 cases and deaths per county. And these are just different shades. There's no distortion, there's no symbols, there's no dots. This is a choropleth map, clearly. All right, let's move on to some other topics here. We're going to move away from the maps for just a little bit and talk about distance, direction, and location. All right? So absolute distance is a measure of physical space between two locations, or people per se, or two environments. It's what you think of when you think of distance in terms of something like kilometers or miles. You could even do it in nautical miles. And typically we use nautical miles when discussing the ocean or another big body of water here. Your GPS gives you something in absolute distance. Relative distance describes the relationship or separation. It's more of a description between two locations of people. So what could this look like? It could look like a non-stop flight from Rome to Paris is 2 hours. We could describe relative distance in units of time. Oh, it's a 10-minute walk, or it's a 3-hour bus ride. We could also say where something is in relation to where you are. Oh, it's around the corner. Oh, it's down the road. Oh, it's just up yonder. You could say it's a short or a long way away. The beach is a short drive away. The amphitheater is a long ways away. Oh, the gas station, it's not that far. That's relative distance. You could also describe it in other ways, like saying it's more expensive or it uses more resources. Flying to Europe from Florida is going to be more expensive than flying to somewhere like North Carolina. Now let's talk about absolute and relative direction. So absolute direction uses your cardinal points. They're universally understood. And your cardinal points, it's just your compass. Go on your compass app on your phone if you don't know what I'm talking about. It's how the pirates navigated, y'all. So this can include measurements like 48 degrees southeast. That's the direction we have to go in. You could say it's north of somewhere or south of somewhere. Florida is south of Georgia. You could say you need to head southwest to find the buried treasure. You don't need to say the actual degrees. You could just give an actual cardinal direction. Relative direction is another description. It's based off the observer's current position and orientation. So if I move 20 miles, my relative direction may change. So you could say turn left at the stoplight to reach the theater. You're not saying turn west because turning left depends on where you are. You could say the Toy Store is 3 blocks away. Blocks are not a set measurement unit. They're not like miles or kilometers. They vary where you are. Some blocks are bigger than others. You could say Germany is next to France. You don't know where it's next to France because Spain is next to France as well. You could argue that the UK is next to France. It's above France, but depending on what you're thinking about, you could say it's next to France as well. Now let's talk about location. Absolute location is the exact location on Earth a place is. Typically, this deals with two things: longitude, latitude, which I guess is two things. They're your coordinates. That's one thing, as well as addresses, which is newer than longitude, latitude. Longitude is your up and down lines on a map, and latitude are your side to side, your hamburger style. They're flat. That's how I think of it. So yeah, longitude, up and down, latitude, side to side. So example of this is longitude, latitude. Los Puertos Hermanos is 35 degrees north, 106 degrees west. You can also give it in the form of an address, like Walter White's house here. It doesn't have to be the whole address. You could just say the zip code. You could just say the city name. It doesn't have to be this long whole thing. So on the AP exam, they ask you for an example of absolute location. You don't have to give this whole thing. You could probably be fine just giving a zip code for one. So just know a zip code, like your zip code. They know it, so they're not going to dox you. Relative location, again, is just another description. If you haven't taken this away yet, the absolutes are the real ones. The relatives are the descriptions. They depend on who you are and where you are. A relative location is a description of a place in relation to another place. Like a landmark, you could say it's right by the red fire hydrant. You could say it's in the northern hemisphere. The car wash is next to the law firm. And you might have noticed that these are very similar to your relative directions and distances. And your relative locations can be relative directions and distances. So you could say the house is around the corner from the lab. That's where it's located, around the corner. It could be a direction. It could also be a location. Interesting, huh? Now, did you know that all maps are wrong? Yes, they are. This map that you sat on in kindergarten is technically wrong. Why? There's a good reason. So, the Earth is round. If you didn't know that, now you do. The Earth is round. It's not flat. It's not shaped like a donut. It's not a pyramid. It's 3D. It's a sphere. Not a perfect sphere, but it's a sphere. And maps are 2D. It's like a piece of paper. Well, a piece of paper is technically 3D, but if you print out something, the picture's 2D. Okay? You can't take something that's 3D and make it 2D without having some kind of distortion. You're going to mess something up. Because if I undo the sphere, if I basically pull it apart and try to lay it flat, it's not going to look like a rectangle. It's not going to look like a flat sheet of paper here. Okay? So as a result, we have map projections. So it's impossible to take a sphere and turn it into a rectangle. So we have what's called map projections, different types of maps that shape the Earth differently. They're a transformation of the 3D Earth to a two-dimensional plane. Every single 2D map, even Google Maps, has some kind of distortion. There's 4 key areas of distortion. So that could be shape, it could be distance. Our shape could be the shape of the continents. Our distance, or the distance between 2 places. When I look at a map projection, I look at the distances between the continents. It could also be the direction. Is South America actually south of North America? There are some projections where it's more east, where it's just so distorted. And also we look at area, and area is one that tricks up a lot of students. Area technically deals with like the size of the continents. Is Greenland really, really big? Because it's actually not that big. And what do you mean it's not that big? Africa is 14 times as big as Greenland, guys. So yeah. So let's look at the Mercator projection. This is the one you're probably the most familiar with. This is the same one that Google Maps and Apple Maps, they all use this one. And I would just like to know, we're going to go over like 6 different map projections. You don't have to memorize any of them. You don't have to know what the Mercator projection is off the top of your head. You don't need to know what the Robinson projection is off the top of your head for the AP exam. Your teacher might be a little different, but your AP exam, they don't care as much about it. All right? They just want you to know why map projections exist and what they can distort, and then they might give you a projection. Most of the time, it'll be probably the Mercator projection, and they're going to ask you what's distorted. Now, looking at the Mercator projection, what do you think is distorted? I mean, I can tell just by looking at it that Antarctica and Greenland look huge. I mean, the further away you get from the equator, the bigger the land masses get. So yeah, what's distorted? The area, the size of our land masses are distorted. Direction is pretty preserved. That's what makes the Mercator projection so good for navigation, like with Google Maps. Because the angles are really good for navigation. You can use your cardinal directions to get from place to place. And the shapes are pretty well preserved as well. I'll give them that. Now, since direction isn't distorted, we can use this a lot for navigation. Now, let's look at the Robinson projection. No, it's not named after Jackie Robinson. That would be cool, though. This is the Robinson projection. You've probably seen it as well. It's good for posters. So what's distorted? Distance, shape, area, and direction. All of these are distorted. They're all distorted in some way. Minimized, but still distorted. I mean, Greenland and Antarctica still look kind of big. This is called a compromise projection. So everything's distorted, distance, shape, area, and direction, but the distortion is minimized. And they do this to minimize the overall distortion. And it's good to have like for thematic maps because it's visually appealing, and it's now let's talk about the Robinson projection. And no, it's not named after Jackie Robinson, as cool as that would be. So what's distorted here? Okay, so Greenland and Antarctica, they look kind of big. So area is distorted. They kind of look curved. The countries look pretty curved. I mean, look at Greenland. The closer you get to the poles, the more curved they are. So shape is distorted. And that's going to affect your direction, because it's curved, and that's going to affect your distance. So yeah, so I didn't say this for the Mercator projection, but your distance is also distorted because area is distorted. If something looks really, really big, you're going to think there's a lot of distance. So yeah, that's just something to know here. So all 4 factors are distorted here, and that's what makes this a compromise projection. Everything's distorted, but minimally. Minimally means that they are going to minimize overall distortion. So everything's distorted to some degree to minimize overall distortion. Instead of having no distortion in something like direction and having a lot of distortion in area. And that's what makes the Robinson projection visually appealing. That's why you see it on posters, you'll see it online. And it's also very good for thematic maps as well. This is the Gauss-Peter projection. This one is really good at showing something. What is it good at showing? It's good at showing the size of the countries, the size. So what's distorted? Shape, distance, and direction. Size is pretty much preserved, but everything else is distorted here. So yeah, this is not a compromise projection. Since area is preserved, we can kind of see the country's true proportions to one another. So yeah, it makes sense that Greenland is 14 times smaller than Africa. South America is 2 times as large as Europe. And Mexico is bigger than Alaska. All right, now I'm going to show you some really cool projections that I know of. So this is the sinusoidal projection. Oh my gosh, it looks like one of those little like tops you used to spin around on the table when you're a little kid. So what's distorted here? Well, Greenland, it looks pretty small compared to Africa. That's always my reference point. So area looks pretty well preserved. South America looks bigger, 2 times as big as Europe. Okay, that's good. Area looks good. But distance is definitely messed up a little bit. Direction is messed up a little bit. Look how curvy this map is. And the shapes, they're curved as well. So everything but area is distorted. It's like the Robinson projection, the Gauss-Peter projection. It's showing the true size of the countries in a different way, but it's distorting everything else. So the Maudlin Integris sinusoidal grid is based on this projection. If you don't know what that is, it's a grid developed by NASA for some like science thing. I don't know what it's for, but it's just a fun fact. It's not developed by NASA. So this projection has some purpose here. All right, now let's look at the butterfly projection here. This one's kind of crazy as well, but it kind of looks like a butterfly. What's distorted? Oh my goodness. So yeah, what's distorted? Well, shape is obviously distorted. I mean, look at how curved some of the countries are. Direction is distorted. Clearly, there's a big gap between Europe and North America. Distance is distorted because of that gap, and area is distorted as well. It's one of those compromise projections where overall distortion is minimized, but they have attempted to minimize it. This one, to me, has a lot more distortion than the Robinson projection. Let's look at some more. This is the Hammer Retro Azimuthal projection. It kind of looks like a pair of headphones, and that's supposed to be Antarctica, by the way. So yeah, shape, size, distance, direction, everything's distorted. And this is the Collignon projection. Collignon projection? I actually have no idea how to say that. I should have. And it looks like a pyramid a little bit. So yeah, this one is used for making maps of cosmic microwave backgrounds. It has some cool science purpose. There's some math behind it. I showed you the equations. There's no math on the AP Human Geography exam, so don't bother learning it. And don't bother learning this projection at all. It's just for me to show you because it's fun. So yeah, that's projections for you. So can you just tell me the truth, Eason? How big are these countries? Well, here's a little picture to kind of show you. And if you like to try it for yourself, go to thetruesize.com. I also made a video on this. If you'd like to go check it out, I'll put a card above this video. If you want to go watch that, and you can learn the truth about how big some of the countries are. Okay, great. All right, so now we're going to talk about geographic data. Now you probably know what geographic data is. Geographic data is locational data, so it's data tied to a place. It's tied to a location where there's descriptive attributes. So geographic data, for example, could be where in the United States do students score the best on AP tests, or in which states do the most students fail AP tests. So we can look at a map and determine, okay, Louisiana, Mississippi, students there fail AP tests more. We could say Florida, California, Virginia, Massachusetts. Those students pass AP tests at a higher rate. Now, this map doesn't say why they pass these AP tests at a higher rate. It just tells us this is what's happening in the world. It gives us the data. It doesn't give us a why or a how or anything. And actually, we could break this down even more. We could let's take Florida for an example. We could break that down to individual regions. We could break it down into individual counties. We could even break it down into individual schools if we wanted to. Data can be gathered through a variety of methods, like organizations and through individuals. Individuals can go out into the street and count cars that pass by, but organizations could find or use some kind of technology to count cars. If you live anywhere where they're doing like a lot of expansion, construction, neighborhood creation, they are out surveying all the time. So here's a concept. It's called toponyms. You're going to hear it pronounced in a variety of ways. All this means is the name of a place. So College Board may throw this word at you. just to confuse you, because it's not a normal word. You don't say it in your everyday vocabulary. I don't say, hey, I was there at the toponym the other day. So yeah, it's just the name of a place. It's literally the name of your city, the name of your neighborhood, the name of your state. The United States is a toponym for the country. Earth is a toponym. Mars is a toponym. Goobertown is a toponym. Portland, Maine. Portland, Oregon. Chunky, Mississippi. Toponyms. There you go. Geographic data could be also physical data, so it could be data about the actual physical geography, the topography of the world. So this could be climate, it could be soil, it could also be temperature, rainfall, it can be mountains, it could be different types of species that are living in different areas. There's a lot that we could interpret and use with physical data. But it could also be thematic data, which is our data that revolves around a phenomenon, a trend. And typically we give more quantitative measures. But this is more thematic data. So it shows just popular brands and corporations throughout the United States. What's the states kind of known for? A little bit. California, where Silicon Valley is, they're known for Apple. In Florida, where we have the beaches and people without clothes on, Hooters. Yeah. And then in Oklahoma, you drive 20 miles, you find a Sonic, and there's nothing else in the whole town. Here's another thematic map. This is a isoline map, I believe. So it's showing just flood numbers events. So it could deal with natural phenomenon, but it's still showing thematic data because we're looking at quantitative information. Another thematic map, this is a dot distribution map. It's showing the number of Dairy Queen locations in the United States. What can we interpret from this map? There's more Dairy Queens in the eastern side of the country than the western side. They're more dispersed in the west. They're more clustered in the east. I mean, look at Texas. It's kind of like a straight line just goes through it. And it just starts going on less and less because nobody lives in western Texas, let's be honest. So we're going to talk about some technologies now. Some of these you might be a little familiar with, and some of these you may have never heard of before. So first we're going to talk about satellite navigation systems. So these are just systems that use satellites up in space to provide geopositioning, like where you are in the world. They use a small electronic receiver to determine a location. They use your coordinates, your longitude, your latitude, but also your altitude, how high you are from the ground. And they do this at a very high precision, so it's very, very accurate. And they use time signals transmitted from the satellite. So what does this mean? So they determine your location very precisely at a specific point in time. So they're not like, let's say I was in South Dakota last week. The satellite's not going to say I'm in South Dakota right now. It's going to say I was in South Dakota last week. And these satellite navigation systems can be used for your GPS. They can be used for navigation. They can also be used for timing different events, as well as remote sensing. And remote sensing is just a very fancy word of taking images with a satellite. So Galileo is the European Union's satellite navigation system. Russia has one. China has one. The U.S. has a GPS satellite navigation system. But the Galileo was created by the European Space Agency just a few years ago to provide a very high precision positioning system so that Europe can have their own navigation system without relying on another service like the U.S. GPS. And this provided a whole new global search and rescue system, something to give it some memory. And recently, an anonymous EU official claimed that U.S. officials imply that they might consider shooting down Galileo satellites. I guess they can't take the competition. So yeah. Let's talk about global positioning systems. What's a global positioning system? That sounds fancy. GPS is a global positioning system. Yes, now you know what GPS actually stands for. The GPS in your phone is a global positioning system. And they're used to identify absolute location, direction, and distance. So these concepts, yes, they have purpose. So what's the use of a GPS? You could get directions to your grandma's house for cookies or to go to White Castle. You could be traveling down to the Titanic if you do it safely. You could be doing search and rescue operations. You could be mapping fields for crops. You could be geocaching. I've been geocaching in years, and making this PowerPoint, it kind of reminded me how fun it was. You could be optimizing pizza delivery times and routes, find which ways are quicker, which ways have traffic in certain areas. They could identify the absolute location with the traffic. They could be dispatching emergency response units. They could tell you the quickest way to get there. They could tell you the distance that you are. So the distance will help determine which fire station goes out to put the fire. They could also be tracking tagged wildlife and tracking the numbers of wildlife to see if certain species are in threat of extinction or not, or if they're migrating. We could also be doing drone navigation as well. There's a lot of uses with global positioning systems, and it all comes down to identifying absolute location, direction, and distance. Now, there are some pros and cons to using a GPS system here. This is kind of a diagram to show how they work a little bit. So these pros can include geographic mapping, as well as just navigation, precision. They're very accurate. Tracking and monitoring you, people, events, as well as being very time accurate. You can conserve the wildlife. Some cons include technology dependence. What happens when the technology goes down or it breaks? What if the signals interfered here? What if these GPS satellites malfunction? They can also be very complex. I'm sure the original GPS was not as simple as Google Maps. There's also be security vulnerabilities. What if someone hacks into a GPS? They could see a bunch of people's locations, and that's just not safe. Now let's talk about remote sensing. Remote sensing is the acquisition of information. So you're acquiring information about something, usually a place or an object, and you're not making direct contact with it. So I can get information about India without actually having to go to India. And most of the time this is done with satellites and taking satellite images. So for the most part, remote sensors collect this data by detecting the energy that is reflected from the Earth. There's a lot of science behind this and a lot of math. And these sensors are usually mounted on satellites, but they can also be mounted on aircraft. So this is a satellite image. It was created through remote sensing. And what usage could we have of this satellite image of New York? What possible reason would we have to take this? Well, we could see how dispersed the land use is. It's not. It's very clustered. We can see if there's any green areas. Yes, there are. There's some environmental promotion here. We can see, okay, how big are the buildings? There's a lot of tall buildings, but there's areas where there's not a lot of tall buildings. We can see if there's any uniform or spontaneous development. It seems that the high-rises are a little more spontaneous, but if you look towards the southwestern part of the image, it's a little more uniform, kind of like a grid-like pattern. I feel like I just push buttons a little bit there. We could see if there's a lot of traffic for this time of day. We could see that there's roads, and if you look in the northeastern region, it looks like it'd be an interstate. And yeah, there's a good bit of cars, and it looks like they're traveling in the same direction. So traffic in that direction is a little more heavy. We could see if there's any damage from environmental events if we would like to. We could also look at the water and see how clean it is. That's pretty important as well. There's a lot we can take away from this image. We can actually look at the architecture and determine the culture. Maybe there's a multicultural significance, or maybe it's very modern architecture. So yeah, very cool stuff. We don't see a lot of agriculture. It's very urban. We can determine cost of living's high. I just keep going on and off. I'll shut up, I promise. Here's another little diagram here. It kind of tells us the usage, though, for satellite imaging. So satellite imaging and remote sensing can show us different organisms. It could show us if there's any viruses going on with our crops, or if there's anything wrong with the canopy or the whole landscape. Of course, we could look at damages. We could look at spots maybe that the farmers missed, or they did too much of, so it doesn't look like it's growing properly. We could look at any diseases that are being passed through to the plants as well. We could look at areas that need irrigation. There's a lot that we could look at related to our agriculture with remote sensing. Now let's look at a GIS, Geographic Information System. You will see this pop up somewhere on the news, maybe with like National Geographic, sometime in the future. And most people don't know what it is. They just kind of nod their head when they read GIS, and they're like, yeah, I know what this is. They don't know what it is. You're going to learn what it is. So without even reading the little stupid statement here, what are we looking at here? So we have the world. You live in the real world. And the world you can take out and create layers. You can make the ocean a layer. You can make the layout of the city just a pure layer. You can make the roads the layer. You can make the physical grass and dirt and in mountains a layer. And then you can make the buildings a layer. You can make everything else one layer as well, your full view, if you'd like to. There's a lot that you can make out of these layers, and it varies at which GIS you're looking at. So, yeah. So we take the world and we comprise it into layers, and each layer provides us with a lot of valuable data. Like the routes layer looks at our roads and the design of the city. We can literally just look at that and see in areas where there's a lot of space for roads and areas maybe where there's not a lot of space for roads. We can see where there's a lot of buildings. Maybe, okay, that's maybe a little more walkable area, per se. If there's a lot of roads clustered together, a lot of alleys, we could say, okay, this is very urban living. Look at the elevations and see what kind of geography we have there. Maybe there's a lot of mountains, or maybe it's very flat. Maybe we're in New Orleans, which is underwater, for one. If the water bodies layer is above the elevation layer, then yeah, that could be a big sign that they are prone to environmental damage. So systematically, a GIS is a computer system. It captures data, it has input of data, it analyzes the data, and it displays the geographic data. And you can analyze it in layers. It captures it in layers. It doesn't take a big picture of it like a satellite image does. So here's another little image, a little diagram to show you what a GIS kind of does. So it takes very simple data, very simple layers, and it just adds more. So the buildings get a layer, the vegetation gets a layer, the routes, like the roadways, get a layer, and then everything comes together to build the world, the real world. This is a GIS of the University of Central Florida. So we can see here that we have the actual map, that's one layer, and then we have a layer for parking. We have a layer for food. If you wanted, we could have a layer for shuttling and traffic. We have a layer for EV charging for your Teslas. So you use GISs on a daily basis, probably, for the most part, or your parents do. So a lot of people use GISs on a daily basis. I use a GIS on a daily basis. So what's a use of a GIS? Well, you could use it for urban planning, like with zoning and land use, as well as where you could put infrastructure. You could use it for telecommunications, like 5G. Look at where areas need 5G, or what areas are more clustered that you might need a little more 5G support to support that many people. You could be tracing pollutants if you'd like to. You could be just analyzing the physical landscape, seeing, okay, where are the mountains located really? Because if you build a big city along mountains, you just maybe want to see what's going on with the mountains. You could see where the rivers are. You could also be using this for insurance company decision making, which is a pretty big deal, because that means that they have to find a way to save money. You can use it for weather forecasting. Some areas may look a little more predictable to flooding. That's a big thing. That also has to go with the insurance company decision making. If they're insuring a flood zone, they're going to charge higher rates. Now, does a GIS require an absolute location like a GPS? Yes, it does, because we're talking about geographic data, and geographic data is tied to a location. So you use a GIS a lot, probably, if you use Google Maps or Apple Maps. So yeah, these are examples of GIS. They're considered online mappings. You can take layered data here. You could have a picture of the actual terrain, or you could do a little more of a diagram focus if you'd like. You can choose if you want to have businesses show up, interstates show up if you would like to. You could show different routes as kind of the GPS incorporation in there as well. So Google Maps is a great example of a GIS. Now, what are the pros and cons to using a GIS? Well, the pros include enhanced decision making, as well as data integration. You can get all of this layer data into one. You can communicate with other people. You can manage your resources. It also can save costs depending on how you use the decision making. It could also be great for environmental analysis because you make the actual physical environment a layer and analyze just that specific layer. You could also do need-based customization. That kind of goes back to the Google Maps here. You could use it for your own specific needs to see where places are, how you can get there, that sort of thing. And then the cons include, of course, technology dependence, what happens when it goes down. It could also be very complex if you have a lot of layers going on. You could use it for data collection and integration challenge. Yes, that's a pros, but it's also a cons because how are you going to collect that data? And you have to collect a lot of data. I mean, look how much, I can't even imagine how Google Maps collected all that data. There could also be some inconsistencies, and it might not have to be put up to date every few years or depending on when the landscape changes. What if the environment changes? What if a volcano erupts and destroys a big area? The GIS will then be inaccurate. So online mapping and visualization, this is just a brief little thing here. So online mapping and visualization is typically done with a GIS, and what it does, it takes the layers and it combines them all into one integrated map here. And it's typically done in a 3D manner so you can visualize what an area looks like. This is Manhattan. I could tell just by looking at the little area, and the island right below it says Statue of Liberty, and because it's in the corner it says Manhattan Population Explorer. But besides that, this is Manhattan, and we can kind of visualize what Manhattan looks like, how tall some of the buildings are. We can kind of get a reference at where Central Park is, where are the tallest buildings located, where are some of the smallest buildings located. We could actually look at where the borders are. Where does Manhattan start and where does Manhattan end? We could see where is it located near water. So there's a lot of uses here with online mapping and visualization. Now let's talk about collecting spatial information. There's a little bit of information here, but we just gotta look at how you can collect spatial information. So this could be through field observation. Just going out and watching animals is a field observation. Watching how people interact. This is done by a lot of psychologists. They actually just see what normal behavior is like in day-to-day life. And that could be very useful for geography as well. They could also collect spatial information from media reports, as well as travel narratives, like the travels of Marco Polo. He described what China was like during their very prosperous Song dynasty, I think in like the 1200s or so around that time. Travel narratives could just be through Yelp as well, leaving a review for a restaurant saying, they made my salad great. So you could say, this place has salads. People like the salads, that sort of thing. You could also be doing it through policy documents. Policy documents can tell you where certain properties start, where certain properties end. You can also just do it through taking photographs of area and say, okay, in this space there's a lot of damage from natural disasters. This is from the Joplin, Missouri tornado. You could also just do landscape analysis. You could literally just go out and look and say, this is rural, this is urban. Or you could look at a picture and do landscape analysis as well. We don't have the whole landscape of Joplin, Missouri, but we got a little chunk of it here. All right, so now we're going to talk about scale. So scale, essentially, is literally what you're looking at. What are we looking at here? We're looking at the world. We're looking at the globe. That's our scale, global scale. For a fancy definition, the scale is the relationship between the portion of the Earth being studied and the Earth as a whole. What incarnation does that mean? Well, the relationship here is that we are looking at a global scale. That is what we're looking at. Out of the world, we are looking at the world, a global scale. Scale determines how much detail is shown on the map. So when we're looking at a global scale, we can look at data from the whole world, every single country, all 195 of them. And sometimes if you're looking at a scale, let's say of one country, a national scale like Australia, we only look at the data in Australia, but we can look at more specific data within Australia. So of course, this is a global scale because we're looking at the world. What's the scale of this? We're looking at Canada. We can see a little more specific information about the inner mechanisms of Canada, but it's still Canada. So it's a country scale. You could also say a national scale if you'd like to. What about this one? This is Buffalo, New York. Buffalo is a city, so we're looking at a city scale. I hope you're catching on to the trend here. So we're looking at South America. South America is a continent. So we're looking at a continental scale. It doesn't matter what the data is. It just matters what are we looking at. We're looking at a continent, so it's a continental scale. Now we're looking at South Asia. We're not just looking at India here. We're looking at different countries now. So it's not a national scale. Since we're looking at South Asia, which is a region, it's a regional scale. Okay, now we're looking at a very local area. I don't even know where this is. I just found a picture of it. It's not a city. It's a little section of a city. It's not a big region, so I wouldn't use regional. I would say it's a local scale. A local scale is just kind of a local area. It's more community-like. So maybe if you have a few streets or so, that's a local scale. Okay, so let's go through a different concept here regarding scale. So we're looking at large scale and small scale. So this map on the left here of Portland, Maine is considered a large scale map. Now, why is it large scale? We're looking at less area. That is correct. But in terms of human geography, large scale means large detail. We can look at individual streets and blocks of Portland, Maine. We can't do this with the map on the right because we're looking at a small scale map on the right, which has smaller amounts of detail to it. We can look at, yes, the individual counties of Maine, but we can't look at what's happening really within those counties. We can't look and get as much data, as much information about the inner workings of Portland with the right map. The left map, we can look at the individual regions of Portland if we'd like to, but we can't do that with the map on the right. So small scale, small detail. Large scale, large detail. The less area that you're looking at, the larger scale you're looking at. It sounds counterintuitive. It sounds like the reverse, but that's just how it is. What would be a smaller scale map than this map of Maine here? A smaller scale map would be a map of the whole United States. A smaller scale of that would be a map of North America. A smaller scale map would be a map of the world. So out of these two maps, we have a map of East Asia and we have a map of just China. Which one's the larger scale map? So the larger scale map has the most specific detail, and that's going to be the one right here, the map of China, because we could look at the individual regions of China. On the other map, we couldn't really do that because it would be very hard to interpret and analyze. So this is the larger scale map. We're covering the lesser area. All right, let's do some more scale. So what is the scale of this data? We're not saying large scale, small scale. We're asking for the actual geographic scale in proportion to the world. So let's see here. Let's read the title. Top 10 U.S. cities with the largest population increase. So we're looking at cities in the U.S. It's not a city scale because we're looking at multiple cities, but we're looking at cities in a country. So it's a country/national scale. What about this data here? 10 fastest growing cities in Texas. Again, so we're looking at different cities, so it's not a city scale, but we're looking at cities within a state, Texas. So it's going to be a state scale. Another term that you can use with these states, sometimes they'll give you provinces of a country like Canada. But if you have a map or in this case a chart or a table with the states. State data, like in the United States or Australia or another country with states. Nigeria is another one. Mexico is another one. You could say state scale, or you could say sub-national. Sub means beneath, so beneath national means it's not as big as a country, it's smaller. Great. What about this one? This is what's considered a population pyramid. We'll learn more about this in Unit 2. But we can just read here that we're seeing the population structure per gender in Western Africa. Western Africa is not a country, it's a region, so it's regional scale. There you go. What about this? This is South Africa. We're looking at, it looks like just a reference map here of South Africa. Now, South Africa is a country. So we're looking at a national scale. South Africa is not a region. If you're trying to talk about Southern Africa, say Southern Africa. If you have to say that on your FRQ, please say Southern Africa. Because if you say South Africa, they're going to think you're talking about the country here. You could say West Africa, that's okay. But say Southern Africa. All right, so here's some more just basic questions regarding scale. I'm putting a lot at you because this is something that students oftentimes can get confused, especially when we learn a future concept in 1.6. We won't get there just yet. We're just going to focus on scale, though. So what scale should be used? If we were creating a map with 4 different maps, what scales would we use here? So let's say we were comparing property tax rates within South Carolina. Property tax rates, they vary per county. So we're looking at South Carolina counties. That's South Carolina. That's a state. That would be a subnational or a state scale. Subnational, smaller than a country. Subnational also has to be within a country. Now, thankfully, most of the world is just countries and oceans, so makes it easier. So comparing the number of Muslims in New England is what we're looking at, and New England is a region, so that's regional. Analyzing which countries Taylor Swift has been on her tours. Her tours have been global. Sometimes you're going to have questions like this. That's going to have to make you think about them a little bit. It's like, okay, where has this phenomenon occurred? Taylor Swift's been all over the world. She's been to so many different countries. So we're probably going to use a global scale if we were to make a map of this. And then finally, what if we were comparing the immigration rates between the 18 French administrative regions? Well, France is a country, so that would be a national scale. Great. It doesn't matter what we're comparing the data between, if it's between different regions, even if it's between different countries, and we're looking at a global scale, between different counties, we could still be at a state scale. It doesn't matter what the data is being compared between, and it doesn't matter what the data is. It just matters at what we're looking at. That's what determines the scale. What are we looking at? Are we looking at the United States? Great, that's a country scale. Are we looking at Europe? Great, that's a continental scale. Are we looking at temperature for the whole world? That's fine. It's a global scale. So let's look at some past FRQs to see how College Board likes to test scale. These are very recent FRQs. So College Board has this in their brain currently, and it's moping around a little bit. So this is from 2023, Set 1 FRQ 3. You'll have 3 FRQs on your AP exam, and 2 of these FRQs will have stimuli. What is stimuli? A stimuli is like a map. It could be a chart. It could be a graph. It could be an excerpt if they really wanted to. It could also just be a picture. It could be a picture of a landscape, of a farm. It could be a picture of a good or a service. It could be a lot of stuff. So you'll have to get used to, reading maps, analyzing pictures, and analyzing charts. If you don't know how to read a graph, I would learn how to read a graph because that could be important on your AP exam. So let's see here. Describe the spatial pattern of companies and institutions shown on the map. So this is an actual FRQ prompt, part A for FRQ 3, and it's asking us to describe the spatial pattern of the company. So let's look at the map because it tells us to. And the map showing us major medical and biotechnology companies and institutions in the Boston and Providence region. So we're looking at the Boston region here. And then we get a little more specific. We're getting into a more local area. So the spatial pattern. Let's look at some actual responses that College Board gave on the rubric. So we could say there's a clustering of economic activities. We could say that. There is a cluster of economic activities here in Boston. There's a concentration among the transportation routes, like the interstates or the rivers. They said arterial roads. That's just fancy. You could have said roads or interstates. There's also a concentration of similar economic activities within a metropolitan area or the Boston metropolitan area. The simplest, though, would be there's a clustering of similar activities. So when it says describe the spatial pattern, it's just asking you, okay, the companies and institutions are clustered together in Boston. They're clustered, we could say, among the rivers, like the Charles River here, or clustered on the interstates and roads, that sort of thing. And then this is another question I threw just to practice at, is what are the scales of the maps? Okay, so the first one's regional because we're looking at a region of the United States. We can see Rhode Island. We can see part of Massachusetts, not all of Massachusetts. You could also say subnational probably, and that would be okay. And then the smaller, little more specific map would be local because we're looking at a very local area of the Boston area. We're not looking at just Boston. We're looking at Cambridge as well, which is 2 different towns technically. So it wouldn't be a city scale. So the big map focuses on a regional scale. They didn't ask what the scale was on the AP exam because they told you for this part here. So we have to explain a possible limitation of drawing a conclusion about the entire country from a regional scale map. So let's say we looked at this map and we said there's a clustering of economic activities among rivers throughout the United States. What's the limitation of drawing a national scale conclusion? So the rubric gave us 4 different answer choices. On an FRQ on the AP exam, you have to have something that's on the rubric. If your response is not on the rubric, or like a synonym of a word on the rubric, you can't get the point. And that's just how it is for almost every AP exam. It kind of sucks sometimes, but that's just how it is. And you'll practice FRQs relentlessly before the AP exam, so you'll get good at saying what's on the rubric and talking in College Board talk like this, because some of this may just sound so foreign to you. It's like, I don't write that way. That's okay. And the rubric has everything in one sentence. You'll be writing these explain prompts in probably 3 to 5 sentences at the minimum. That's okay. All right, back to this FRQ though. I'm sorry if I stressed you out a little bit. So what's a limitation of drawing a country scale conclusion from a regional scale map? Well, let's read. I'll just read it straight out. A limitation would be it attempts to analyze research data from one scale of analysis to make claims about another scale of analysis, may be inaccurate due to change in scale's effect on spatial analysis. So essentially what you could say is attempting to discuss data from multiple scales would be inaccurate because they're in different areas. Yeah. You could say, so making research assumptions from map data at one scale of analysis to claims about another scale of analysis may result in inaccurate calculations or ecological fallacy, or these are just fancy words. You could literally just say it's inaccurate because we're looking at different areas, because we're looking at different scales, and the world is different. That's essentially what they want you to say. And then the region can be specialized in a sector. So more economic definition is that the Massachusetts region is more specialized in a certain economic area or industry. And different regions throughout the country specialize in different economic practices. The United States is a big country. There's more areas specialized for farming and more areas specialized to more service-based industries. Like in Silicon Valley, that's a very, very much so tech-oriented area. But in areas in Nebraska, they're farming. In Idaho, they're growing potatoes. They're not making Apple laptops. And then the last one, the region can have a long and continuing tradition of valuable or productive sectors that are very different from the changing mix of economic sectors that categorize the country's economy. So what this says is that Boston's has a tradition of economic prosperity. I mean, look at the colleges. That's probably what someone would talk about, is the colleges. Is that the productivity in Massachusetts is long-standing. It's been going on for a long time. And then in the rest of the country, it's changing very rapidly. In Massachusetts is a lot more historical because Massachusetts was one of the original 13 colonies, so it's going to be a lot more historical there. A lot of the practices in Massachusetts, particularly in Boston, have probably been going on for hundreds of years. I mean, Harvard, MIT, all the other universities there have been there for hundreds of years. They have practices set in stone, very traditional economic practices. So another limitation question. So what's a limitation of using this map here to understand the geography of religion in present-day Africa? So let's look at the map. Larger cultural groups in West Africa. Now, religion is a cultural trait. Religion is not a culture. Religion is a cultural trait. So that kind of sets us up there for our response. But let's see what we could have said. The map shows cultural groups which are not synonymous with religions. That's what I just said. You could also say the map only shows West Africa, not Africa as a whole. If you read the question, it says present-day Africa. So it's difficult to understand what's happening with religion at a continental scale when we have only data from a regional scale. There are many cultural groups in Africa that have populations and individuals practicing different religions. So it's impossible to know which religion is practiced in a given area. There might be cultural groups that practice different religions. In the United States, the American nation has so many different religions here. We can't just categorize the United States as a Okay, this is a Baptist country. This is a Catholic country. No, because so many people practice so many different religions. We also say this map only shows areas where the cultural groups are the dominant. It doesn't show the minority cultural groups. It doesn't show any diversity of cultural groups or diversity of religions that may be practiced in those areas. It also doesn't have a key. If you notice, it doesn't have a map key or a map legend. So you may not be able to interpret or analyze this information that well. And that kind of sounds like a stupid answer, but College Board will do that on purpose. They may not give you a map key because they want a student or two to say, yeah, there's no map key. How am I supposed to analyze this information? Because map keys are pretty important sometimes to analyzing the information. And look here, it's a choropleth map. So hang on. So it doesn't show us what these shades mean. What in the world do the little dots mean or the lines mean? So yeah, that's pretty cool. Okay, one more FRQ for this topic. So another limitation. College Board loves these limitation questions. Explain a possible limitation of using this map to describe the political conflict on the island of Ireland. So there were like 8 responses. I didn't pick all 8 because some of them had to do with the politics unit, and we haven't done the politics unit yet. So I chose specific ones to go out of here. But what's the map showing? The map is showing 2 countries, Ireland and the United Kingdom, and it's not showing any thematic data, so it's a reference map. So what's the limitation of using this map to describe the political conflict? Well, you could say the map doesn't provide detail on what's causing the political conflict. It doesn't show what's happening culturally or religiously at a regional scale or even a local scale at Ireland. So we don't even know why the conflict's happening. It's just showing us the countries. It also doesn't provide any information regarding where the conflict's occurring. Maybe it's occurring in the whole country. Maybe it's not occurring in the whole country. It's not, by the way. For the most part, it's occurring near the border of Northern Ireland and Ireland. I'm not going to explain it too much, but essentially, the Catholic nationalists of Ireland want to make Northern Ireland part of the whole country, while the Protestant Unionists in the United Kingdom and Northern Ireland don't want that to happen. They want to stay part of the United Kingdom. And then there's another question, what is the scale of the map? Well, we're looking at 2 countries. That's what the map key shows us. We're looking at the Republic of Ireland, and we're looking at the United Kingdom. So we're looking at a region, technically. So it's a regional scale. Why is it not a national scale? A national scale only shows you one country. If we were looking at just the United Kingdom, or we were looking at just Ireland, or we were looking at just Iceland, or Canada, or Mexico, or one specific country, then it's a national scale. Now let's talk about the national census. This is something that I know you're going to hear in your class or read in your textbook. So I want you to learn about it and learn about it right. So what's the national census? You may have an idea of what it is already. So a census, a lot of countries do a census, and they are just to count the population. Count the population of the country, count the population of a nation, or just a specific area, like a state in the country. It records information from the population, not just the numbers, but it can also include information about the age of the population. Maybe they have a more older population, or they're finding out that they have a very young population. They could also look at gender. Maybe they have more males than females within the country, as well as occupation. Maybe they want to see how many farmers there are, how many people are involved in manufacturing, how many people are involved in services, how many people are teachers, how many people are involved in tourism, and the variety of the economic sectors within the country. It may also include data about the region's agricultural and business sectors. It could show what areas devoted to farmland or not. The United States Census is conducted every 10 years, every decade, and historically, in every single time besides 1 year, it was done with door-to-door servicing. They had hundreds of thousands of officials go and knock on the doors and ask you questions for the census. Like the main question was that they got from every household was how many people live in the household, because they wanted to count the population. That's what the census is, essentially. It all comes down to counting the population. That's the main goal. Everything else kind of comes after that. In 2020, the most recent national census, the next one's in 2030, the census was done remotely. You could have done this online, you could have done this over the phone, or you could have mailed it to the Census Bureau. Now, the census is not perfect. It's the best that we have, but it's not perfect. It typically undercounts homeless people. For one, in 2020, homeless people typically don't have access to the internet as much as people who are not homeless. And people may be counted twice if they move. This was a lot more prevalent probably without the digital census when they knocked on the doors, because they can't just all knock on the doors on the same day. It's a long process. It's months and months of knocking on doors and asking people, how many people live in your house? What race are you? How old are you? What's your gender? That sort of thing. So people who move, they may be counted twice, maybe sometimes 3 times if they're that lucky. So let's look at some census data so you can kind of get a sense of what the census is. The census is important to the government and certain businesses, but it's also important to you because it gets you to know what's happening within your country, what trends there are. You can actually look at data within your local community and just see what's happening in the area that you live or the state that you live. People have a lot of pride in where they live, guys. So let's look at Louisiana. Louisiana will be our state of focus. So the census gives us data like the total population, and it'll say, the year that the census was taken. So this is 2020, the most recent census, and the population was about 4.65 million. It can give the change in population. So the change in population was from a 10-year period from the last census to the 2020 census, and this shows a positive growth in population within Louisiana. It's not a whole heck of a lot of growth, but there's some growth. It's about 2.7%. It tells us how many houses there were. So there were about 2 million housing units. So this is houses, this is trailer homes, this is apartment units. So on average, there's a little above 2 people per household. So yeah. And then there's a vacancy rate. How many houses don't have people in them? And that's about 12%. As well as the percent change in housing units. This is just the same thing. How has it changed since the last census? We can look at the census data and go a little more specific than the entire state. We can look at the individual counties. In Louisiana, they're actually called parishes. So we can see here, what are the most populated parishes? So East Baton Rouge Parish, that's near the capital of the state, has the most people. Then there's Jefferson Parish, the New Orleans Parish. Orleans Parish is in New Orleans, and so on. You can go down and see what the least populated counties are in the state. We can also look at a map of census data. This is very useful because we don't have to read a chart. We can just look at a map and say, okay, where are the trends happening? Where are these clusters of populations? We can see here diversity index. This is comprised of all the data of the different races and ethnic groups and different people living in the states. So the diversity index shows which counties are the most diverse and which ones are the most homogeneous. We can see the most diverse ones are the ones closer to the cities, closer to Baton Rouge, closer to Shreveport, New Orleans, that sort of thing, which makes sense. That's typically how it works. And then we have another map here. We have the percentage of population that are an adult. So our adult populations are typically higher in the north and then in the south in Louisiana. And we also have a percentage here that 76.7% of Louisiana is an adult. 23.3% are kids. Other data here, we can look at specific races. Where are certain races concentrated? So we could see that American Indian and Alaska Native are concentrated in certain counties, while there may be little to none in other counties. Same thing with Black or African Americans. We see a lot more Black and African Americans closer to New Orleans and Shreveport than in other areas of the state. And then this is the rent, actually. For not different areas, but different cohorts of value. So what percentage of people are paying certain amounts of rent? So for the most part, 40% roughly of Louisiana is paying either $500 to $999 for rent per person. This is per person, by the way. It's not per household. So who uses the national census? I said that, businesses, governments, and even you can use the national census, and that's true. So a bunch of people, a bunch of organizations and corporations and individuals can use the national census at local scales, regional scales, and country scales. So government agencies can use census data to plan and implement policies, which is legislation, which is law. And they can do this related to education, like who needs more schools. They can do this for healthcare, who has an aging population that may have more healthcare needs, as well as housing. Is there a high housing vacancy rate? Maybe we don't need to build housing because there's housing available. As well as transportation services. Where are populations clustered that may need more transportation to support one another? As well as social services, again, with that aging thing. Where is there a more elderly population that might need more social security plans? As well as economic development. Where are the more urban areas occurring? Are people all moving to one area? That probably means that there's economic prosperity happening in that area. So we can look at which schools may need more funding because they have more students now. What counties need more schools or housing or transportation because of increased population growth? Which healthcare programs are needed in specific areas like vaccination programs? Private sector organizations like businesses can use census data for marketing, planning their business. They could use it for investment decisions. What areas look good to invest in? It can also help businesses understand who their consumers are. Maybe their consumers, for the most part, are of a certain race or a certain age or even a certain gender. I'm pretty sure makeup companies target women more than they target men. They could also look at labor market trends. They could look at regional economic conditions. Maybe areas aren't good to put a business, so they're not going to put a business there. They could also look at potential market opportunities. So they could look at where is everyone moving? That's a lot of population. That's a big market. We should open up an Olive Garden there. So some other specific examples would be retailers could analyze census data to identify target markets, decide on where they want to put store locations. Because remember, the point of a business is to make money. So they're going to put their store locations in areas that'll make them money. They could tailor marketing strategies to specific consumer demographics like culture and age. A business in India is not going to do well if they have a lot of beef products. So they won't tailor their company with beef products in India. A little more specific is real estate developers. They can use the data on where to build houses. Maybe there's a housing shortage in place. If they have a housing vacancy of 30%, they're not going to build houses because there's houses available. Maybe they could build a lot of mansions if they're in a high-income area. Or if they're in a low-income area, real estate developers will develop lower-income housing. Let's continue. So we can look at environmental organizations. Where is everyone moving? Where are the population densities really, really high? Because that means that we're putting a lot of strain on the environment and our environmental resources. And we can advocate for more sustainable development practices. If we're building a lot of housing, we're probably cutting down a lot of trees. Maybe we need to put in some conservation efforts to preserve the environment. We could also have city planners use the census to assess where population growth is occurring. We could actually look at what they're called census tracts, and we could see in a city what regions of a city see the most population growth. We could see if maybe certain areas of the city are becoming more concentrated with men, women, maybe with families or retirees. We could look at needs to build urban infrastructure like roads or electricity services. We could look at public services like transportation, as well as just community development in general. Architects and engineers can use census data to design buildings and infrastructure that meet the needs of diverse populations. Maybe they have populations that have a lot of disabilities. They have to put in a lot more maybe disabled parking and other services, as well as focusing on sustainable needs. If they're in an area with a high population density, maybe they're going to promote environmental sustainability a little bit more because of that increased strain on the environment to support that many people. Manufacturers can even use census data to see, okay, where are the educated people are located? Maybe they need a more educated workforce. Maybe they don't need them. Maybe they can put in training programs somewhere, or even forecast future labor market trends. Maybe they say, okay, this part of Louisiana, that's where our labor is probably going to come from, so we need to target that area. You can also use it. Like I said, you can know what kind of community you're in. You can assess housing and neighborhood trends. You can even use it for entrepreneurship. Maybe you live in an area where business is booming, or you're in a high-income area. You can use it to start a business. You can also use it for political engagement to see, okay, maybe certain politicians will help areas like mine the most, and that can influence your voting or your campaigning if you want to run for an election. Let's look at satellite imagery. So satellite imagery, it's just something else college where it says we have to discuss a little bit more. How might satellite imagery be used at a national scale? So I'm just going to go through these quickly. So national agencies like FEMA can use satellite images to allocate federal disaster relief funds. So they can look at environmental damage. They can just monitor what the environment's looking at. And they can divert their resources as needed. Governments use imagery for surveillance, military operations, and intelligence gathering. They can use it for security. National infrastructure projects like interstates that cover the whole country, like I-95 covering the whole East Coast, can be planned with better information on the geography of certain areas. Maybe there's a more hilly area. They're going to have to spend a little more time building the interstate there. How might a satellite image be used at a local scale, like within a city? Farmers can use the imagery to monitor crop health, soil conditions, and water usage. Local governments can use it for zoning, like for schools, land use planning, and managing public services like water facilities. Businesses can use imagery for site selection on where to build their businesses. They want to build it away maybe from an interstate if it's too loud, or it's just hard to get to the location. I see sometimes stores and stuff driving down the interstate, and there's no exit. I'm like, where are these stores just at? How do you get to them? They could also be monitoring construction progresses with the satellite imagery as well. So look at some examples here. So a typhoon in the Philippines about 11 years ago, I think it's Typhoon Haiyan. You can also see Yolanda if you'd like to. They used satellite imagery to extend the damage in the Philippines and see where the damage was most prevalent and where they need to plan the emergency response here. So this is an actual satellite image. We can see the before and after. There's a considerable amount of damage here in this region. The image helped finding the most severely affected areas, finding which areas weren't really affected. And it also allowed for the diversion of resources to these affected areas, as well as timely rescue operations. They could quickly see where they needed to probably send the search and rescue operations. It also helped in mapping out necessary rehabilitation and reconstruction efforts. What areas were destroyed? We also use satellite imagery to monitor North Korea. Yes, we do. Countries like the United States, South Korea, they use it to monitor their North Korean missile tests. They don't want them getting out of hand because they don't want the world to blow up. They monitor their military activities. And this is used for security purposes, defense purposes, and making sure that there's compliance with international agreements. We actually use satellite imagery with oil spills, like in the Gulf of Mexico, to see the extent of the damage, see how big the oil spill really was, what areas were contaminated, where cleanup operations needed, how big were these cleanup operations. We could also look at the environmental impact here, as well as use it for legal purposes against responsible parties. Who was responsible for the oil spill? Look what you did. It was X big, and it caused X amount of damage. That's what the satellite images told us. Okay, let's move on to spatial concepts now. So we're just going to talk about a bunch of vocab for this topic. So a place. A place is a specific point on Earth. It has particular characteristics, like physical and human-made places. So, for example, Florida is a place. The counties within Florida are places. Florida is pretty flat. That's what makes it a place. It's a peninsula. It has unique characteristics. Colorado is not a peninsula. Absolute location. We've learned about this before. It's just the exact location on Earth. So it could be something like an address, or it could be the coordinates. So here I have the address and coordinates to Dinosaur Park in South Dakota, because I just wanted something cool to show you. Then we have relative location, which is a description. It's not the exact location on a place. It's not universally fundamental, but it's a description in relation to another place, like a landmark. So Massachusetts, it's close to New York. You could say that I am by the red fire hydrant. You could say the elementary school is around the corner from the prison. That's bad infrastructure development. Georgia is along the Atlantic Ocean, that sort of thing. Then we have space, and space is just the physical gap or interval between two objects or places. So you can say, how far is the border of Florida from the border of South Carolina? And that's the space, is the gap between those two states. And then there's flows, which is the movement of people, goods, information, ideas, that sort of thing between different places. I wanted to show a diagram of the Columbian Exchange because that's one a lot of you are familiar with. And then I saw this and I thought this was cooler. So this is a map. It shows the flowing dudes between refugees from the countries of former Yugoslavia. So countries like Serbia, Albania, those countries are. And it's showing where these refugees are going to. It's a graduated symbol map. And it's showing that most of the refugees are going to Germany, and while some of them are going to Italy, some are going to Austria and Sweden and Norway and the UK. Very few of them are going to Ireland. Very few of them are going to Portugal and Greece. Some of them are even going to Turkey. 35,000 of them are going to Turkey. So we can see here it's a movement of people. You could also argue it's a movement of culture as well, because the cultures in each of these individual countries in Europe are drastically different. Now let's talk about something called distance decay. There's math, Eason. You're freaking me out a little bit. Do not worry. You don't have to learn this equation. You don't have to do any math on the AP exam. Do not worry. Deep breaths. I just thought it was cool to show you and to scare you because I'm kind of evil like that. So distance decay. What is distance decay? Distance decay says the further away you get from somewhere, the less likely you are to interact with it. So if I lived in Massachusetts, I'm close to New York. I'm more likely to interact with New York than Florida. There you go. That's distance decay. So yeah, the more space there is, the less interaction there is, the less communication, the less likely you are to travel there. It might be more expensive. It's going to be more expensive. You're using gas, it's going to be more gas. And you might have less knowledge on the place. If you live in Oregon, you're probably going to have less knowledge on Georgia. If you lived in France, you're probably going to have less knowledge on Nigeria than Germany. So yeah, you're more likely to speak the languages and have more cultural elements the closer you are as well. You're more likely to eat locally. You're more likely to root for local games. Like if you live in Georgia, you're more likely to root for UGA than for FSU, which is in Florida. You might be more aware of local events and news, as well as socialize with locals. You're more likely to talk with someone you meet on the street than talk with someone who's 10 states away. So let's look here. I have a little map here of a town in Norway. So let's say you're staying at the hotel here. It says your hotel. I even pull out the pen for this in case you can't see it. So this is your hotel. Where are you more likely to park your car? In parking lot 1 or parking lot 2? According to distance decay, you're more likely to park in parking lot 1. Makes sense. If you're staying at this hotel, are you more likely to go to the science factory, or are you more likely to go out to the guest harbor? You're more likely to go to the science factory because it's closer to your hotel, according to distance decay. So yeah, that's what distance decay. If you're in the hotel, are you going to interact with people who are on a street by your hotel, like this one, or a street by the harbor, like this one here? It's in Norwegian, so I can't pronounce it. Well, you're more likely to interact with people on the street closer to your hotel. That's distance decay. It seems like common sense, but now it has a vocab term for it. This is just, there's a lot of math behind distance decay. People are predict how far you have to be for the distance. Not how far you have to be, how far you be according to the interaction. They're trying to measure interaction, which can be a little challenging to do. There's a lot of math behind it that I don't understand, and you don't have to understand either. So let's move on to time-space compression. This is another phenomenon that you're probably a little familiar with. You just don't know the actual definition for. So time-space compression. Essentially, we've made a lot of advancements and innovation in technology. We have iPhones, and we have Echo Dots, and we have all kinds of cool technology, as well as transportation system. We have automobiles. They didn't have automobiles 150 years ago. We have airplanes. They didn't have airplanes 150 years ago. We have steam engines. They didn't have steam engines 500 years ago. So we can get to places a lot quicker and a lot more efficiently. And this has made the world feel smaller. What it's done is reduce the relative distance. There you go. On the AP exam, they ask you, what is reduced with time-space compression? Relative distance. And that makes the world feel smaller. It doesn't shrink the absolute distance. It's still thousands of miles from Georgia to Italy. It's the same distance it was hundreds of years ago, but it feels smaller because I can talk to people in Italy with my phone. I can get to Italy in under a day if I wanted to. So the world felt a lot bigger before airplanes. Airplanes was kind of the big one for this, because this made transcontinental travel, like over the oceans, speed up like that. Because I mean, it took Columbus 61 days to travel to the Bahamas from Spain. It can take less than a day now to go to and from these countries. You can travel more quickly. You can travel to more places. There are places like Antarctica. We couldn't get to Antarctica before as easily. It's a lot more easy to get to Antarctica than it is now. You can exchange more information. I can talk to people in Italy and tell them what's going on in the United States a lot more quickly and a lot more efficiently. Because I don't have to send a letter anymore, or I don't have to go there. So I could send PDFs of 300 pages to people in Italy if I wanted to. I could exchange more ideas as well as goods and services as well. And that's opened up international markets and multinational corporations. So let's look at some specific contributions of time-space compression. So that includes air travel, high-speed rail. I don't know why I did the animations wrong. I'm sorry, guys. I'm not perfect. Cars made time-space compression a thing. The internet, it allows us to use stuff like Instagram and Discord. Telecommunications, like your phone. I can call people in the United Kingdom if I wanted to. Container shipping allows for the mass movement of goods and services. Multinational corporations. We have corporations like Apple that are operating in different countries. Like, oh, you have an Apple phone? I have an Apple phone. You're from India? I'm from Mexico. That's great. Oh my gosh, it's like we're in the same world. We have global media that's accessible throughout the whole world. I can see what's happening in Pakistan, and I can see what's happening in my country. I can see what's happening in Nigeria. I can see what's happening in the United Kingdom because media access globally. Now, what are the effects of this time-space compression besides, just reducing the relative distance and making the world feel smaller? Well, we have, of course, the increased efficiency in transportation and communication, and that's led to better trade. It's led to economic growth, substantial economic growth, because businesses are now able to operate more efficiently. They can compete better, and they can just exist in international markets. We can see people being brought closer together, people talking to each other more and to people further away. We see greater cultural exchange as a result. We see people getting these technologies in higher demand. Governments want these technologies as well. Businesses want these technologies because they want to talk to people at a higher scale. And this has occurred internationally. So time-space compression has happened across the entire world. And of course, the effects of these technologies like cars are a transportation technology that's led to traffic have become evident. Traffic didn't exist 150 years ago. This is a picture of Atlanta. Atlanta has some of the worst traffic I've ever seen. I've seen bad traffic in Boston. I've seen bad traffic in Dallas. Cars make traffic. That's just how it is. People don't make traffic. Cars make traffic because on average you have one or two people in such a big car. If I've seen videos of people like in cars but without the cars, so it's just a road of people and everyone's so spread out. Cars make traffic. That's what causes traffic. That's the effect. It's not people. Now there's pattern. Pattern's a pretty simple thing. It's just the arrangement of objects in relation. So we see a pattern in Manhattan here of the buildings are in a grid formation. That's the pattern here. We see the pattern is that the Central Park is a rectangle. There's no big buildings in Central Park. That's the pattern here. What patterns do you see here in this satellite image? This is of light coming out of the world through buildings, advertisements, lampposts, streetlights, you name it. This is just light coming out of the world. So we can see here that light comes out of more developed countries in Europe and North America, particularly Eastern United States, as well as South Asia. So the more developed the countries are, the more light is being emitted from there. For the most part, these are areas along the coast as well, because that's where the most urban areas are. All right, so they actually asked about pattern a few years ago on the AP exam in 2021. This is actually from my AP exam. I did this FRQ on my AP exam. It was not fun. Anyways, so the map shows several specialized manufacturing clusters known as special economic zones. So it's showing different zones in China. So first off, what type of thematic map is this? This is a dot distribution map because we're using dots to represent the clusters. So the part that we're discussing is describe the spatial patterns of the clusters located on the map. So what is this really asking? Where are the clusters located? What's the pattern? The pattern is they're located along the eastern coast of China, or the southeastern coast of China, located in the eastern side and along the coast. You could also say they're located along the cities, the urban agglomerations, or just the urban areas. College would use a lot of these big words in their definitions, but you don't have to say them. You can say they're located near the urban areas. I said they're located along urban areas on the eastern coast of China. There you go. And that's why I got a 5. It's just a specific part. Not really. All right, let's talk about natural resources now. So natural resources is what you think they are. They are resources that come from the environment. They are created naturally. Oil is a natural resource. We get it out of the ground. It is made naturally on Earth. It's not infinite, but it's made naturally on Earth. Wind is natural, so we can use wind power. The forest, timber, natural resources. It's grown here. Diamonds and lithium and granite. They're all natural resources here on Earth as well. Water is a natural resources. Animals are natural resources on Earth. Natural gas is a natural resources because the gases are naturally created. We can artificially create a lot of gases too, but natural gas is a natural resource. So yeah, those are natural resources. So what are the most traded natural resources? Oil is a natural resource most traded. Mineral, natural gas, and coal and forest. Now, what's the trend that I want you to look at here? The trend is the first 4 of these are non-renewable resources. They are not unlimited. So that's something to consider here. Forests are considered renewable. However, if you chop down all the forest, you have no forest anymore. So they are considered renewable because you can plant trees. And planting trees is cool, and Mr. Beast did it. So you can do it too if you like. So yeah, let's move on. Let's talk about sustainability. I've already briefly touched on this a little bit, and this is a term I'm sure you've heard. You've heard it from people who try to scare you that say the world's going to end in 10 years. You've heard it from people giving you the paper straws and melt in your drink. You've heard it on the news. You've heard it from your friends, your teachers probably. It's so common nowadays to hear the word sustainability. What is sustainability? Well, sustainability deals with how humans operate and how humans use land. One of the biggest parts of human geography is just studying how humans utilize the land. And more specialized area that a lot of people spend their entire lives focusing on is sustainable land use. So sustainability, the definition of sustainability is when you use Earth's natural resources like oil or the forestry, and you use it in a manner that doesn't curtail their future use. What does that mean, curtail their future use? The word curtail means to withdraw, to remove. So what this means is that you're using the resources in a manner that they can be used in the future as well. You're making a balance here. You're meeting the needs right now, and you're meeting the needs of the future. So you're not destroying the world for the next generation, essentially. So some examples of what's considered a sustainable practice would be using energy-efficient lighting, water conservation. If you get rid of all the water, people won't hydrate and they will die. Cycling and walking, overusing your automobiles. Recycling your plastic so it doesn't end up in the ocean. Planting trees. Not dumping oil in the Gulf of Mexico. Not disposing uranium into public landfills. And not overfishing. Because if you overfish, you have no fish and you can't make sushi. That's pretty important. I like sushi, and I would hope that future generations have sushi. It's a lot more than that, but I'm not getting into the big nitty-gritty about it. So these are examples of sustainable practices. So is this sustainable, having a trash river in India? No, it's not. This river look at videos of it. It still flows too. It's just trash flowing. And yes, there's some water with the trash. Would you like some water with your trash? Essentially, it's the river Ganga. It is a real river in India. This person appears to be bathing in it, and that's just disgusting. Oh my gosh. So yeah, this is not sustainable. This is not meeting the needs of the future. I'm sure people once used this river for a lot of resources, like for bathing. But nowadays, future generations really can't bathe in this. They can't really drink out of it. It really serves no purpose now because it's full of trash because they were not sustainable. let's talk about two concepts. We're going to talk about possibilism and determinism. So environmental determinism. This states that the natural environment determines and plays the biggest role in how humans use the land and how cultures develop. So example, it's like, why do humans not live in Antarctica? Because it's too cold there. The environment made it so we can't live there and flourish. We can't build cities there. Why were the most prosperous cities originally developed along the coast? These should be question marks. I'm actually going to change that because that's bothering me a little bit that I made such a stupid mistake. Boom. Boom. Anyways, why are the prosperous cities originally developed along the coast? Because that's where the fertile agricultural land was. That's where you could leave through boats. You could travel very efficiently. You could fish. So the environment made us settle originally along the coast or bodies of water like rivers here. Then we have possibilism, where it states, yes, the environment limits us to a degree. However, humans are great because we can overcome these limitations. It is possible to overcome the environment. So let's look at the image here on the left. Hawaii. Hawaii is in the middle of nowhere. It's in the middle of the Pacific Ocean. However, it's one of the biggest and most desired tourist destinations in the world because we have developed technologies that allow us to build big cities there, that allow us to travel there, and has allowed it to become a very big tourist spot. And then here on the right, this picture from China. This is called terrace farming. A lot of China is very hilly. It's not very flat in certain areas. And a lot of the areas where they grow rice and a lot of other agriculture areas, they needed to farm because they support the big population. China has over 1 billion people there. So they got to make do. So what they did was they've done something called terrace farming, where they essentially make stairs on the mountains, and that allows them to farm efficiently. And they've overcome this limitation of farming in a hilly area. So
now we're going to talk about scale of analysis. So we've already talked about scale, which is the relationship between the portion of Earth being studied and Earth as a whole. So if we look at a map of the world, like the one on the left, we're looking at a global scale. But if we're looking at a map of a particular country, like the United States, we're looking at a national or a country scale. If we were looking at a map of Europe, we would be looking at a continental scale. Scale is literally what we are looking at. Are we looking at a country? Are we looking at a continent? Are we looking at the whole world? Are we looking at a region or even a state or a city? Now, scale of analysis is something a little different. So scale of analysis is the spatial extent to what is being studied. What is the data being compared between? So is the data varying between continents or countries? Is the data being compared between states? Or is it not being compared between any entity at all? It doesn't have any confined borders here. So look at the cartogram on the left. What's the data being compared between? It's being compared between nations, countries. So it's a national, or you could say country, scale of analysis. What about the one on the right? That is a national scale because we're looking at a country. But what is the scale of analysis? What is the data being compared between? Well, the data is being compared between, it varies between states. So you could say it's a state scale of analysis. Another term you could use is subnational scale of analysis. The prefix sub means below, so it just means below national. We're going to do a lot of practice with this. So here we have a map. It just shows population of one of the hemispheres, not even the entire hemisphere, but just a little region of it. So what is the scale? The scale is regional because we're looking at a region of the world. What is the scale of analysis? What is the data being compared between? Well, the data is being compared between different countries. So it's a country scale of analysis. The data varies between Brazil and Mexico and America and Canada and Peru and Ecuador and Argentina and Bolivia. It all varies between the countries. It doesn't go any more in depth than that. We can't see anything between the individual states of the United States. We just see something for the country as a whole. And College Board may ask you that. They may ask you just what is something that the map shows. And an answer choice could be it shows that the population in X country is the same everywhere. That's not true because we're looking at a national scale of analysis. We're not looking inside the countries. We're looking at the country as a whole. All right, here's another one. We're looking at the world, so that's a global scale. Now, what is the scale of analysis? It varies between countries. Again, it's just at a global scale, so it's still national and country. All right, here we're looking at a map of climate regions of Africa, and I boxed regions for a reason. We are looking at a continent, the continent of Africa, so that is our scale. And then what is our scale of analysis? Well, sometimes the title or the legend or the citation of a map is going to help us with this, and in this case, it's our title. It says major climate regions. We're comparing different set regions within Africa. So this is a regional scale of analysis. We're comparing reference data, not really quantitative data, more qualitative data. We're comparing where are the rainforests in Africa, what climate zones are in Egypt compared to Nigeria or South Africa. Egypt is all desert, while South Africa has a very, very small portion of the country being a desert. In a tropical desert. It has a lot of subtropical desert, but not a lot of tropical desert. Egypt's more tropical desert. That's a difference there. Nigeria is tropical. It has rainforest, though, but it also has grasslands and semi-arid climate areas in the north. So that's what we're comparing. We're comparing the climate zones and where they're located within Africa here. We're not comparing them exactly between the countries because the countries have multiple climate zones here, and the climate zones stretch across multiple countries as well. All right, here we're looking at a map of the United Kingdom. We're looking at different areas within the United Kingdom. So the scale is national because the United Kingdom is a country, and then the scale of analysis here is regional and subnational, whichever one works for you. I would say on the AP exam, subnational would probably be the best answer on an FRQ, but on the MCQ, they would probably say regional. So that's why I put both here. So England, Scotland, Wales, Northern Ireland, those are all regions within the United Kingdom. They're not country. A lot of you would probably say that they're countries, but a country is not composed of other countries. A country is composed of cities and towns and sometimes states and provinces. Like America has states, Canada has provinces, France has administrative regions. In the UK's case, they're just different regions of the country. Wales is a region, Scotland is a region, England is a region, and Northern Ireland is a region as well. So when we're looking at a map comparing population between them, that's a regional scale of analysis. Subnational also works because these different regions are smaller than the country. Here's another one. We're looking at a map of China, which is a country, so it's a national scale. And then we're looking at the rankings between major cities in Nigeria. Which ones are the biggest cities, the top 10 biggest cities in the countries? What's the population within those cities? And what's also the disposable income per person? We have a lot of different variables here in our data, but we're still comparing the data between cities, 10 cities. So what's the scale of analysis? It is cities because the data varies per city. All right, here's another one. We're looking at a map of the world, so we're looking at a global scale. And then what's the scale of analysis here? Now here's a hint. Is the data being held within certain borders? Is it being compared between certain districts or regions? Not really. Is it being compared between countries? No. What is it being compared between? It's not being contained, that was the word, to any specific entity. So it's a global scale of analysis as well. Most of the time, you'll see global scale of analysis when dealing with heat maps like this. A lot of times dealing with climate or temperature or rainfall. You don't typically see this without a heat map. You don't see it really with choropleth maps. You don't see it with dot distributions as much. That does happen, but heat maps are sometimes the best. This is also a proportional symbol map, and that really only works because the data isn't going to be spread out all over every single continent. You can see the clusters and dispersals very easily with the symbols here. But when you make all the countries really small compared to having a map of just one single country, if you have a lot of symbols, it's going to be very, very confusing to read. Like I can't really read what's happening in Europe because there's so many symbols in the way.
So that's kind of a disadvantage to using a proportional symbol map for a global scale. All right, here we don't have a map, we have a chart. So the title, always important. So we're looking at GDP across the globe, which is our scale, because we're looking at areas around the globe. And then the key helps us with our scale of analysis here. So we're comparing data between Asia, Africa, Europe, and the Americas. Those are all continents, so that's a continental scale of analysis. It doesn't matter what the data is. It doesn't matter when they're recording it, how they're recording it, how it'll change, how it has changed. It just matters what the data is being in between. We don't know what's happening inside Asia. We don't know where this GDP is concentrated. We don't know where GDP is low in Europe. We just know that this is the share of GDP as a percentage of the world over the past 2,000 years. That's it. Okay, here's another one, more of a large-scale data set here compared to the world. We have a specific state in the United States, so that's our scale. You could also say subnational as well because it's smaller than the country. And then what's the data showing? It's showing distribution of blueberry production in Maine. The data is not being compared between counties because some counties have different data within them. So like Hancock County has both intensive and moderate production. If this was a county scale of analysis, Hancock would be one or the other. It wouldn't have both data sets here present on the map. Yeah, I lost my train of thought for a second. And look at Washington. Sometimes it has no production, and then it has intensive production as well. So we're getting a little more specific than the counties. So I would just say that's a local scale of analysis. We're comparing the production between local areas because there's a lot. Sometimes there's places in Maine where there's a lot of blueberry production. The more north you get, I kind of see that there's a lot more production, especially intensive production. But the more south you get, there's a little less production, but it's more moderate production here. And that varies depending on the local areas. Okay, here's another one. So we're looking at the South, which is a region, is a subnational region. So it would be regional scale. Subnational could work as well. And then the scale of analysis. Is this local? Yeah. On a multiple choice question, local would probably be the answer here. But on an FRQ, they're not going to want you to say local because they want to distinguish between the students getting a 4 and the students getting a 5 on the AP exam. Students getting a 4 would probably put local. Students getting a 5 would say county because the data is being compared between the different counties of the United States here. You can get more specific than county, and that's when I would say local is the best answer here. But it's being compared between the counties. We can see here the population change between the different counties in Louisiana and Arkansas and Oklahoma. We can't get any more specific than that, though. All right, here's another one. We're looking at a state, again, this time California. So our scale is state, and then our scale of analysis is going to be county again, because we're comparing the data, the engineering job listings, between the different counties. We can see that there's not a lot of engineering jobs in the northern counties, but in the southern coastal counties particularly, there's a lot of job growth there. All right, here's another one that's not a map. We're looking at, looks like different states within the United States. Yeah, these are all United States data. So our scale is country. We're not really looking at a specific region here. California and New York are on opposite sides of the country, so rules out regional. And then the scale of analysis. It looks like we're just comparing data between states, nothing more specific than that. So the scale of analysis is state, or you could say subnational. Sub means below. So if it's below national, it means below the country, smaller than the country, like New York is smaller than the United States. All right, here's another one. I underlined and boxed another thing because that could be important. So we're looking at Boston neighborhoods. First things first, Boston is a city. So we're looking at a map of a city. So city is our scale. And then what is the scale of analysis? Well, it tells us that the data is by census tract. That's the scale of analysis because the data is varying and can be compared by the census tracts. Now, what are census tracts? You may have never heard of that before. Census tracts are the regions within a city, a town, literally everywhere throughout the 50 states where census data is linked. So they don't link census. They can link census data to an entire state or to an entire county or even an entire city like Boston. But they can get more specific than the city as a whole and give you certain areas of the city, certain districts, they're called tracts, certain tracts of the city. So you can actually get down to the nitty gritty and see where in your city certain foreign-born population is, where in your city population growth is evident, where the higher incomes are located, where certain racial groups live, where the median income is found in the city. So it helps you get more specific and more detailed in your research and your analyzation of a place with the census tracts here. So, like in this case, we can see who's foreign-born in Boston. What neighborhoods is there a lot of foreign-born residents? Like Chinatown has a lot of foreign-born residents. East Boston has a lot of foreign-born residents. While West Roxbury doesn't have as many foreign-born residents. So yeah, that's pretty cool. And we were looking at a city scale of analysis, which is where we're comparing data between cities. Boston would be just one color. New York would be just one color. Atlanta, one color. Seattle would be one color. You can't get more specific than that. But now that we're looking at a more census tract scale of analysis, we can see where in the city the certain populations are located. And this is created through census data. This would be probably a better answer. Local would be a better answer if we were not looking at census data, because then it probably wouldn't be confined to census tracts, because census tracts are linked to census data. Okay, that was a little bit of a mouthful. So these are some sample questions without any stimuli, just to kind of get your brain thinking about what these maps should look like. So what scale of analysis should be used to compare property tax rates within South Carolina? Okay, so let's think for a second. Property tax rates vary between counties. So that's going to be a county scale of analysis, because that's what you would compare them between. All right, the next one. Comparing the number of Muslims between the states in New England. That question had the answer in it. New England is our scale, but state is our scale of analysis, because that's the data we're comparing. That's what we're comparing the data between. And the next one, analyzing which countries Taylor Swift has been to on her tours. Well, she's been on a world tour, so that's a global scale. And then that's going to vary which countries. That's going to be a country scale of analysis, or you could say national scale of analysis. If you want to get more specific, you could probably say city or regional scale of analysis, subnational scale of analysis. And then the last one, comparing the import-export rate between ports in Florida. Okay, so Florida is our scale. That is a state scale. And then ports are located throughout the peninsula, for one. So are ports linked to a city? Well, a city could have multiple ports. A city could have no ports. And yes, a city could have one port. But what's important is that they could have multiple ports. Like Jacksonville, Florida is the biggest city in the country geographically. So I'm sure they have more than one port in Jacksonville. While smaller areas like Port Charlotte, Florida has a little less, maybe has one, maybe a few more ports than that than Jacksonville does. So we're probably going to be looking at a more local area here. So that's what I would say is the scale of analysis. Not city, not county, but local. All right, here's a multiple choice question for practice. Which scale of analysis would provide the most detail about population change within Arkansas? All right, so we're looking at a state. So that's subnational state. That's our scale. So we can actually rule out E because that's our scale, not our scale of analysis. The only times that scale of analysis and scale are going to be the same is when they're global. All right, so which provides the most detail? Which one will get down to the nitty-gritty, will be the most detailed? So is that going to be county or city or regional? Well, regional can be bigger than city because a region can be comprised of multiple cities. So we're probably not going to say it's regional. It's probably not the best answer here because we got a lot more specific responses. All right, now let's compare county and city because sometimes a city is only located in one county, but oftentimes a city can be located over multiple counties. So I don't think it would be city in that case or county in that case. Because it goes both ways. And then we're left with census tract. Are we dealing with census data? Yes, we're dealing with population change, which is census data. So we can look at individual regions, individual areas within a city and get the most detailed data from a census tract scale of analysis. All right, now we're going to look at regions. We spend a whole few minutes on regions because they're important. So regions are just areas in the world that have unifying shared characteristics or some kind of patterns of activity. So they have typically a shared culture, like the South has sweet tea, country music with banjos and fiddles, as well as Southern architecture, like with the columns for one. There's a lot of other parts of Southern culture. The accent, for one. When you go up north to New England, people typically don't have a Southern accent. That's part of the Southern region. That's what unifies the region. Okay, so let's look at some different regions throughout the world. I'll try to guess where these regions are located, what these regions are. These are all unifying common characteristics throughout the region. So what region of the world is this? This is the Nordic region, which is composed of Denmark, Sweden, Finland, Norway, Iceland, those very cold northern states of Europe. So yeah, it's really nice there. I really want to go there. I mean, look how beautiful this is. It looks so lovely. All right, here's another region. Here's a hint. Regions can be composed of multiple countries, or regions can be within a country. They can be smaller than a country. So as a hint, this one's smaller than a country. So what region of the world is this? This is Tuscany, which is a region of Italy. I've been there. It's really, really nice, and they have good bread. All right, here's another one. You can probably tell, okay, this is in Asia. What region of Asia is this? This is East Asia, which has Japan, China, the Korean Peninsula, Mongolia, as well as some other areas of Asia as well. Okay, here's another one. This is Sub-Saharan Africa. This one's probably a little harder for you to guess. Sub-Saharan Africa is a term you're gonna hear throughout this course. What does Sub-Saharan Africa mean? Well, the prefix sub means below, so it means below the Sahara, below the desert. So the desert is that gray part of the map here, and then the blue is below that, Sub-Saharan. And yeah, it's not very developed. They do have some cities. There's a lot of farming going on, a lot of rural development. The Serengeti is also located there. That's what that big picture is. So yeah, those all unify and are common characteristics throughout Sub-Saharan Africa. And you could get more specific than this. There are regions within Sub-Saharan Africa, but these are common characteristics that can be found throughout Sub-Saharan Africa. All right, here's another one outside of Africa, if you didn't notice. These are really nice pictures, by the way. I really like the picture in the bottom right. I just like the colors. I think it looks cool. So yeah, this is the Caribbean. The Caribbean, don't get mad at me. And, very tropical, a lot of tourism. They have a lot of coastal cities. You can see here as you get further inland towards the mountains, there's less development. That's typically how it works with cities. A lot of tourism, a lot of bright colors to attract consumers. And it has money from tourism as well. So it looks really nice and wealthy. All right, this is in a desert, obviously, so it's definitely not the Caribbean or the Nordic region or even East Asia, for one. Some parts of East Asia has deserts, but it doesn't have Muslim architecture, so it's definitely not East Asia. What area in the world has Muslim architecture and desert? The Middle East. So yeah, this is the Middle East. The architecture does look nice. I will give them that. All right, so College Board gives us, for AP Human Geography, a list of world regions. And you need to know this map. You need to know which countries are in which region. So you need to know that Brazil is in Latin America, but Brazil is also big. You need to know where Australia is. You need to know that Central Africa is in the central area of Africa. And you hearing me say this probably makes it sound like common sense. But do you know where Micronesia, Polynesia, and the Melanesia is located? Maybe not. You should probably learn that first. Micronesia is on top, Polynesia is on the bottom. East Asia. Which countries are part of East Asia? Which countries are not part of East Asia? What about South Asia? Is Vietnam part of South Asia? No, it's part of Southeast Asia. So it's little things like that you have to learn. What's the difference between Western and Eastern Europe? Is the Netherlands in Western Europe, or is it in Eastern Europe? There's no Central Europe in this case. So when College Board on the AP exam, or on AP Classroom, or anywhere else for that matter, says Western Europe, you got to think France, Netherlands, Italy, Belgium, all the way to Portugal as well. It also includes Finland and Denmark and Iceland.
as well. So that's pretty important. Latin America, they don't have a Central America in this case, it's just Latin America. Some people will say that Central America is in one place, Latin America is in another place. No, in this course, from Mexico all the way down to Argentina is Latin America. Look at where Egypt is. It's in northern Africa here. It's not in the Middle East. If you look back at this slide, this map said that Egypt is part of the Middle East. College Board disagrees, and sometimes that happens. Regions are not the same from person to person in a lot of cases. So regions can be contested. They can vary depending on the perception of an individual or a government for that matter. So let's look at the 3 types of regions. So the first type is a formal region. These are the ones that are not up to debate. They're based on defined political boundaries. They are recognized globally, and they will not vary from person to person. They're typically formed by some legal document like a treaty, oftentimes drawn up after a war, because historically how you got land was through war or conquering it. So some examples are states like New Hampshire or Tasmania. Tasmania is a state in Australia. England is a formal region of the United Kingdom. We have property lines, official property lines, so where your house is. If you're in a planned community, or if you have certain land out in the country, or just anywhere for that matter, there are lines saying where your property starts and finishes. That's not up to debate. Those are legal documents here. Electoral districts are formal regions as well. And then regions about culture, like German-speaking regions of Switzerland. That's not up to debate, because you can't really say that people speak German in areas where they actually don't. And then physical geography is a formal region because it's where the physical geography is. It's not up to debate. You can't say the Everglades is in Georgia. There's no wetlands there. So the Everglades can't be in Georgia. And then you have the Amazon rainforest as another example. Valleys, the Grand Canyon, those are all formal regions as well. And then we have functional regions. Functional regions revolve around a function, also called a node. And they are a central hub. They're not often in the middle of the region, but they link the rest of the region together. So let's look at some examples. JFK Airport. The airport is the function. The rest of the region is composed of where the airplanes fly to, where they come back from. That is the region. Port Royal, that's a port near Hilton Head in South Carolina. The port is the function, where the ships go and which ships go or where they come from. That's what links the region together. Radio reception areas, where the signal is transmitted from, the satellite or the tower. That's the function, the node. And then who can receive the signal is part of the region. If I'm in Oregon, I'm probably listening to a radio station in Oregon as well. If I go to Arkansas, I probably won't be able to hear it because I'm not in the region anymore. Now, another example is power grids and other utilities like water and sewage and what's another one? Gas. These are all linked to certain areas. You get local power, local gas, local sewage, and those are typically managed by facilities located near you. So that the region it's a local region for one, is going to revolve around where that function is. For example, let's say there's a water treatment plant by your house. That is the hub. That's the function. And then the surrounding area is the region because they receive water that passes through the water treatment plant. A newspaper route. So the newspaper where it gets printed, that's where the function is. And then the route is the region of who gets the newspaper or not. All right, and then we have a vernacular region. Now, these are the regions that are up to debate. They can vary amongst different people. They can vary amongst organizations and businesses and also governments. They are up to interpretation, okay? So mental maps. If you haven't drawn a mental map before, you should. It's kind of fun. Draw one from your house to your school. That's an easy one. And just label different places on the route there. It's going to vary between person to person. If you get your mom or your sibling to draw the same type of map as well, it's going to look different because your perception of your local area is different from everyone else. You are unique. The South, the term the South. Where does the South start and end? Is Florida part of the South? Florida is the southernmost state,
but is it part of the South? That will change from person to person. The Midwest. What is composed of the Midwest? Where does the Midwest start and end? It's the same deal with the South. It's up to interpretation. Silicon Valley is also the same way. The Rust Belt. What states are part of the Rust Belt? Some states that were formerly part of the Rust Belt may not be a part of it anymore because cities like Detroit have been manufacturing less and less. Latin America, we were talking about this earlier. Is Latin America from Mexico to Argentina, or is Latin America only South America? We also have the Middle East. Is Egypt a part of the Middle East or not? I don't know. What about Turkey? Is that part of the Middle East or not? Some people say that Israel shouldn't be a part of the Middle East because it's not a Muslim majority country. It just varies from person to person. The Outback in Australia. This is more of just a common folk term now. I'm not from Australia, but in America it's just a common folk term. Nobody's referring to a specific place. But I'm sure in Australia they are referring to a specific place, and that can vary from person to person. So let's do some practice here. So we're looking at physical geography first. So the Swiss Alps are mountains in Switzerland. They have glaciers and alpine vegetation as well as mountainous peaks. So they're very high. They reach elevations of up to 46,000 meters. So this is a formal region. The easiest way to interpret this is that we're looking at physical geography here. And physical geography, for the most part, is a formal region. It doesn't say that it's a function. It doesn't say that the agriculture revolves around the water that goes down the mountains. It doesn't say that at all. It just specifically talking about the mountain area, which is a formal region. It's not up to interpretation because the mountains are physical. You can measure where they start and end. All right, here's another one. It's talking about emergency service zones. They have various response agencies like police departments, ambulance services, fire systems also come from ESCs. They are agencies that share resources, and they respond effectively to emergencies within a zone. That's pretty important. We're talking about zones. So certain fire stations are going to respond to fires in certain areas because they don't want to travel too far away because they may not get there in time. They want to get there as efficiently as possible. So counties typically have multiple different fire stations, multiple different ambulance bays. Police departments, they may have one. If they're bigger, they're going to have multiple because they're going to have to respond to probably more crimes in different areas, but they're going to respond in different zones. So that's going to make this a functional region. That specific ambulance bay, that specific fire station and police department that has its own zone is the function. So that's what makes this a functional region. So we went through maps and what is cartography and how do you read a map and why maps are wrong. We went through geographic data and how it's collected. We went through scale as well as the power of geographic data like what the census does. We went through spatial concepts like distance decay and time-space compression, as well as human environment interaction like sustainability, as well as determinism and possibilism. We went through scale of analysis and regional analysis. We went through how to identify scale of analysis and how to identify the different types of regions and how regions can vary from person to person. All right, and that's it. I do have some multiple choice and free response practice tests in the description down below. Thank you so much for watching. Please like and subscribe. It really does help me out. If you have any questions whatsoever, leave a comment down below or message me on Discord. I have more AP Human Geography videos for future units or even this unit, so go check them out. I'll see you guys in the next video, though. Adios!